Okay, we are back and better than ever. We are talking about independent events and how to prove that events or show that events are indeed independent. And to do that, all we have to do is show that the formula given to us is true. For probability, your formula sheet is your very best friend because it is confusing. But these formulas, the formula sheet makes it much, much easier for you. So let's take a quick look at this example. We are asked to show that these events are indeed independent, and the events are two coins being tossed. And event A is the event of getting two heads, and event B is getting a 5 or 6 after rolling a die one time. Okay, we have to show that they're independent. Well, we're going to show they're independent by showing that the probability of A intersect B is equal to the probability of A times the probability of B. And that's true if and only if those are true. So since it's easier, we're going to tackle probability of A times probability of B. What is the probability of A? Of getting two heads, tossing two coins is 1/2 times 1/2, which is 1/4. And when a die is rolled, B is the event of getting a 5 or a 6. Well, on a fair die, that's 2 out of 6, which is equal to 1 out of 3. So probability of A times probability of B is 1/4 times 1/3, which is 1/12. And now we just have to show that probability of A intersect B is equal to 1/12 without using this, because that's what the formula is. So we have to use something different. Well, the easiest way is to make a grid, which I just took the one out of the book here. Very simple to do. A die, the possibilities are 1, 2, 3, 4, 5, and 6. Tossing two coins, all the possibilities are here, which is a total of 24 possibilities, 4 times 6, obviously. And only 2 out of those 24 satisfy these requirements, that we get two heads and a 5 or a 6. And so 2 out of 24 is equal to 1/12, and therefore we have shown that the events are independent. Here we're given some data. The probability of an event A is 1/2 and B is 1/3, and probability of A union B is equal to P. So we're asked to find P if A and B are mutually exclusive. Well, that's scary, except for the fact that we have a beautiful formula right there for mutually exclusive events, where probability of A union B is equal to probability of A plus probability of B. Well, probability of A union B is my P. 1/2 plus 1/3, probability of A plus probability of B, and that is equal to 5/6. Find P if A and B are independent. Well, if A and B are independent, then we can use this formula here for combined events. Because if they're independent, we're going to find probability of A intersect B there. There's going to be something there. So we're going to say probability of A union B is equal to probability of A plus probability of B, need a parenthesis there, minus the probability of A intersect B. Well, we've already got this part from up here. That's 5 out of 6. Well, what's probability of A intersect B? Well, we are told the events are independent, so we can use this formula to figure that out and take the probability of A times the probability of B, which is 1/2 times 1/3, so that's minus 1/6. So that's going to be 4/6 or 2/3. No problemo. Okay, last example, it's the longest one. We are asked to find the probability of B and then the probability of A intersect B prime. This is the harder one to understand. We have to use what we are given. We are given the probability of event A, okay? And we are given that the probability of B given that A has occurred is 1/3, and the probability of B given that A prime is equal to 1/4. So we are stuck with this formula right here, with the A given B formula. So we're going to have to figure something out to be able to find the probability of B. So to do that, I want you to consider two Venn diagrams with events A and B and kind of look at this formula here for just a second. I am not going to be able to isolate the probability of B by itself in that formula, but I can do intersections, okay? What do I have here? I have B and A. So what does B intersect A look like? Well, it looks like that's that section right there. And what does B intersect A prime look like? Well, what does that mean? That means the intersection of set B and everything that's not in A. So that's all of this right here. All this stuff. So that means that B intersect A plus B intersect A prime. If I take those two pieces together, I get B. This piece plus this piece gives me all of B. So the same is true for their probabilities. And that is the strategy I am going to use to find the probability of B. Okay, so let's start off. Probability of B given A. So this is for part A here. Probability of B given A is equal to, I'm going to use this formula, I just have to switch everything. Probability of B intersect A over probability of A. And that's why I'm not going to be able to isolate the probability of B down here. You might think, hey, Becker, there's probability of B sitting right there. Well, that's never going to be isolated because the second thing that's given is either A or A prime. So that's why I have to go through this thinking process. I'm going to use a little bit of algebra because my goal here is to find the probability of B intersect A. Well, if I multiply both sides of this equation by probability of A, then I get the probability of B intersect A is equal to the probability of A multiplied by the probability of B given A. I just multiplied both sides by probability of A. So probability of B intersect A is equal to the probability of A, which is given, 2 over 5 times the probability of B given A. Hey, that's given too. So that's 1/3, or 1/3, and that gives me 2/15. So I've got this part. Okay. Well, by the same token, I'm going to be able to get P of B intersect A prime using this same formula, this formula right over here. So the probability of B given A prime is equal to probability of B intersect A prime, same thing I did up here, over the probability of A prime. This is fantastic, which implies, algebraically again, that probability of B intersect A prime is equal to probability of A prime times probability of B given A. Okay, so let's figure this out. Probability of A prime. Oh no, they don't give it to us. Where's probability of A prime? Well, they don't give it to us, but they give probability of A, which is 2/5. So that means that A prime is 3/5 because an event and its complement must add to 1. Probability of B given, oops, this should be A prime here, sorry, and there is a prime there. Probability of B given A prime is 1/4. So that is equal to 3 out of 20. So I've got this now. So to get the probability of B, I just have to add those two. The probability of B is 2 out of 15 plus 3 out of 20. Common denominator of 60 gives us 17 out of 60. Easy peasy pumpkin pie. All right, and B is a little bit easier. We have to think just a little bit. Okay, we have to get probability of A intersect B prime. Well, what is that exactly? If you're ever unsure, and in this case it's going to be gold, draw a Venn diagram to see what it looks like, and that might help you solve it. So this is A, this is B. So let's think about it. So the probability of A is everything in this circle, intersect B prime. In other words, the intersection of A and everything in A that's not in B. So that's this area in here. Okay? But we know most of this already. We know that the probability of, where is it, B intersect A, this part right here, is 2 out of 15. And we also know that the probability of B intersect A prime, this area over here, we found to be, what, 3 out of 20. And we also know that the probability of A intersect B prime, let's think about this, is simply the probability of A minus the probability of A intersect B. Well, I'm given the probability of A. The probability of A is equal to 2/5. And I know that the probability of A intersect B, well, that's right here, 2/5 minus 2/15 intersection, or the probability of A intersect B prime. And 2/5 minus 2/15, after we get a common denominator of 15, is indeed 4 out of 15. A thing of beauty, nice and neat and clean. Hope you enjoyed it. We'll see you next time.